Greetings and welcome to the latest episode of Digital Engineering, the Manufacturing Tools of Tomorrow. I'm Jeffrey Winters, Editor-in-Chief of Mechanical Engineering Magazine. And in today's conversation, Speeding Innovation, the impact of digital twins on real-world testing, we'll be discussing ways that digital twin technology is shaping manufacturing from the factory floor to long-term maintenance. I'm joined by two recognized experts in implementing digital twin technology. Rahul Garg is industrial machinery and heavy equipment industry leader at Siemens Digital Industries Software. And Travis Harris is chief technology officer at Tech3 Innovation. Mr. Garg, Mr. Harris, welcome. As we begin, I'd like to give a shout out to our sponsors, without which this conversation could not take place. You can get more information on them at the resource section of the console that you're watching this video on. Please check that out when you get a chance. Now, I think most of our viewers today are aware of digital engineering tools in terms of design software and simulations, but digital twins represent a substantial step forward. Digital twins are real-time simulations of physical objects that are in use. And they combine sensor data in a way that enables engineers to virtually test a machine for problems while the actual machine is up and running. But these guys know a lot more about it than I do, so I'm just gonna get started and dive in. So let's start with you, Mr. Garg. How does a digital twin differ from other sorts of computational models?
So thank you, Jeff, and very happy to be here. I guess a couple of things, right? The way I think of it is the computational model is going to tell you and help you understand what may happen in the world, what could happen with your real product. Whereas the digital twin is telling you what is happening with your product, what is currently going on. So you are getting that real-time update and real-time sense of what's currently happening. So to me, the computational models are always incomplete, and they are many times simplified views of what could be happening. The digital twin closes the gap and the inaccuracies caused by simulations by feeding back actual data from the physical twin.
Okay, Mr. Harris, anything to add to that?
Yeah, I would concur. I like to think of it also, I'll just add that like a computational model would be similar to like a flight simulator, where it can teach you how to fly the plane and you can interact with it, but it's not going to per se predict the design of the aircraft or also the failure of the engine itself. So the digital twin is going to give you a deeper insight into what's really going on with the machinery.
Okay, and while I've got you there, in my mind, I'm thinking of a digital twin as a combination of a computer model plus incoming sensor data from the actual physical asset. Is that essentially it? Or are there other components of it? I mean, you kind of flesh that simplified model out for me a bit.
Exactly. You have the physical asset, the virtual asset, whether it's going to be in a dashboard or a 3D model that's overlaid with that data. Also, most digital twins, you're going to have some type of cloud server that's going to make it available remotely, sensors. But another key part is the historical data of the sensors, those past events that you'll be able to bring in to tag information in there, some other components.
Yeah. And artificial intelligence, Mr.
Yep.
Garg, is AI a component of this?
Yeah. In fact, artificial intelligence and machine learning becomes a very important ingredient to add into this mix, right? Because that's what is going to help you do your prediction to understand what could go wrong in the future. And obviously, there are other elements that come into the picture as well, along with the cloud computing and some of the other pieces. Just highlighted things like big data analytics, blockchain, edge computing, so that you're not bringing all of the sensor data back into your servers. You can control that obviously need a very high speed 4G, 5G networks. So a lot of the core technologies that are needed to enable this are now available. And that's why we are seeing a better and more aggressive adoption of the digital twin capabilities.
Yeah, I was going to ask that because that it seems like that's especially the data is probably in past that was probably a bottleneck. I mean, there's only so much data that could pass through through data networks. Is 5G technology and sort of high speed internet, are those implementing technologies for digital twins?
Absolutely right, especially when you're thinking about the factory floor or some of the other places where you're trying to get that real life feed, right? So a combination of edge computing and 5G technology makes that possible, right? So first of all, you use edge computing to help determine and get the right data across. So you're not sending everything over, right? And then once you have that right data sorted through, then you leverage 5G capabilities to get that higher speed bandwidth. And get, because the real time data feed becomes very critical, right? So the more real time you are able to get that information, as Trevor just highlighted, you're flying that plane and trying to get real time information. So you need that real time, so that data to come back to you.
Right. And this actually can be for either of you. I'm not sure who'd like to jump in. I mean, how, in terms of the factory floor, how does the digital twin technology speed the cycle of product testing? When you're making products going through there, is there a way that you can use digital twin technology to make sure that you're producing the products or the widgets in a way that that are up to what specification?
Yes, I can take this one. The project lifecycle can benefit from not having to do, for example, destructive testing. I come from the semiconductor background, and a lot of the tests, you actually destroy the wafer. It costs a lot of money to produce, to validate a design. So I can see the digital twin being used in that way to save cost on those tests, and also just give you an analogy from the semiconductor background. You deposit films on the wafer, and you have inline metrology to do measurements. So by enabling a digital twin of a virtual metrology machine, you no longer have to have that asset that costs millions of dollars sitting on the factory floor. So that's going to, in essence, lower the cost of testing and speed up the process.
And is it just useful for sort of factory fresh parts, as it were, or can it be used for examining a part or a product throughout its entire life cycle?
I think so. We're seeing like simulation analytics inside of like CAD programs. So if you're able to tie that in, and then with artificial intelligence, it should be able to give you the insights to make design tweaks without having to build a product. Or think about if you have a third-party supplier, you have to send that out, wait for it to return, do your test, and keep doing that loop over and over.
Mr. Gard, jump in there.
Yeah, for sure, right. So just to add on to what Travis said, so first of all, if you take full advantage of the digital twin, then your entire user base becomes your proving testing ground, because they are currently using your products, they are currently running it. You are getting real-time feedback from that process. So they are effectively becoming your testers while they are using it as well. So obviously, from a testing perspective, you are getting very, very valuable and insightful information that you can then leverage to improve your next generation products, right? So it really becomes a very valuable mechanism to determine what you do next when you see how the products have been used. Typically, what happens is in most testing environments is you define some boundary conditions and you go in and verify your product functioning under those boundary conditions, right? And you say, oh yeah, I think it should work for these parameters, and I've verified it. But those boundary conditions may not be the only conditions under which your product may be run under. So the vast scape that a user could be using a product for could be a lot different than your boundary conditions. So that's where the digital twin helps you tremendously in helping you build a very broad test case, a very wide test case, and kind of prove it out on how it's working. And then obviously the more important piece is bringing that information back so you can continuously upgrade and redesign to meet those customer needs.
Okay.
So
sure. Staying with you, Mr. Garg, could you, I mean, is there a way to, I'm not sure if you're able to speak to it. I don't want to give anyone to give away any like trade secrets, but are there any sort of like specific use cases that you could you know, or anecdotes that you could tell me about?
Sure, right. You know, so we at Siemens, are selling digital twin software, right, to enable companies to design, simulate, manufacture their parts, and we also sell a lot of those components as well. Siemens is a big manufacturing company as well. So within our own company, we use the digital twin technology for supporting many of our own products that we make. We make engine turbines. These engine turbines are now fitted with a lot of the capabilities that we are talking about, and that information is coming back to our factories from the field usage, and they are using it real time to understand the performance of those turbines, and then making appropriate changes in the way the turbine blades may be mounted or may be crafted. So a lot of that technology is becoming very well leveraged as we speak. So right, the next generation turbine blade that will be created has more better understanding of how it was getting used in different parts of the world. So the designs have improved dramatically for us.
Right. And from the customer's point of view, I mean, are they just getting a better product next time that they buy something, or from the customer, from the user, is there a way that they can leverage this information coming in from the digital twin?
From a customer usage, obviously they get a better product, but the higher value that they get is ensuring, for example, Trevor mentioned improved service, right? So when you are running a product, your service improves dramatically by having that digital twin, and by having that digital twin, you are able to proactively ensure that any issues that may be coming up are addressed before those issues come up. You're proactively able to further fine-tune the performance of your equipment, right? So how it is running, under what conditions it's running, you can further make a lot more changes based on how it may be performing at any point in time. And because you have the digital simulation models, you know that, hey, if I was to increase the speed or increase the torque out here, I may get some better results, right? So I can do that. So having those parameters in your hand make it a lot more easier for you to make those changes. And so they definitely get a lot more advantage as well.
Mr. Harris, you want to jump in there?
Yes, I would just like to add that from my experience, I would also have seen that the digital twin was able to provide even deeper insights than, let's say, some of the engineering teams had anticipated. I'll give you one example. In the semiconductor background, we use what's called copy exact, where for each piece of equipment, you set all the same parameters exactly as everything for that family of tools. But what we didn't take in consideration at this time was the fact that this equipment may have a piping turn that's different just because of the limitation of the factory. So the digital twin was able to point out that the digital fingerprint of this tool, even though it had the same process, was different. The conductance had changed. So you also can get a deeper insight with that performance of that tool from the digital twin that otherwise you wouldn't have got by looking into the whole ecosystem of the process,
right.
A holistic approach.
Right. And And in terms of predictive maintenance, this is something that it seems like digital twins might be very useful for. Do you feel like this is predictive maintenance will be sort of like the killer app for users of products when they're implementing digital twins?
Jeffrey, exactly. Raul can chime in here in a second, but my personal view is that that's the best ROI out the box for a digital twin, because most of your cost in the advanced manufacturing space comes around your equipment and your assets. So if you're able to predict failures, you're going to reduce downtime, you're going to plan your maintenance better. Also, you're going to prevent defects and scrap, which also adds up, and you're going to give the customer a better product overall.
Yep. I think that's spot on. That's spot on, Travis. You minimize the disruptions. You improve your product performance, right? If you can do that predictive maintenance, proactive maintenance, you improve your overall performance of your product. And we are beginning to see some of those things, right? Where a company may find that, hey, if I was to make some changes in the way that machine is running by tweaking some software elements that are controlling that machine, I can become a lot more effective. I can get a lot more throughput. So definitely all those things become a lot more possible now.
Okay. Does the switching up a little bit here from the manufacturer and the user, how does the advent of digital twin technology change the skill set needed by engineers? I mean, are there things that early career engineers need to start training for in a world where digital twins are going to be used widely and relied upon? Mr. Garg, you want to start with that?
Sure. I think that's a very, very good question. Personally, I think engineers will now need to start thinking about multidiscipline, right? Because a digital twin is just not one design principle, right? It's just not a mechanical design only. It is everything combined. It's got the automation in there. It's got the electrical in there. It's got the behavior logic in there, the software in there, right? So all of that is together. So engineers will need to start thinking about multidiscipline systems engineering, bringing all of those pieces together. Data analytics, right? That's going to become another important piece. How do you really understand the data that you're getting back from the usage from the physical twin, right? So and how do you incorporate that? So these are some new things that engineers will need to start thinking about to take advantage of the digital twin.
And Mr. Harris, you're a young man. I know that you didn't start off, working on digital twins. What are the sort of things that you needed to pick up in order to become an expert in it?
The one thing that for me that helped a lot was, believe it or not, SQL. Being able to query a database to get the information and knowing the data sources of your company and the data warehouses, that was one of the most challenging parts. And I was actually thankful that early on as an engineer, that because I was trained to make, data decisions. That's kind of like our company motto at the time, that we make data-driven decisions. So from there, I was able to leverage all of the time that I spent analyzing data and learning my process, learning how to analyze the data. So I was able to use those skills onto working on the digital twin at the time. But data science, data analytics are key points that new college grads, they have to pick up on. And I like to use the term, kind of what Raul was saying, systems are so complex that electromechanical engineer is really what you want. Someone that's a blend of a mechanical engineer and electrical engineer, because the systems requires the skill sets in both. And there's no difference when you're building a digital twin. You need both skill sets.
Interesting. Also, and I'll stick with you, Mr. Harris. I know that the company you work with now is working on AR and VR applications. It seems like that could be a real interesting, interface for accessing a digital twin.
Yes. Currently, right now, you're starting to see companies are using the HoloLens 2 to display real time in 3D using a 3D model of that actual asset with the sensors live. The benefits of doing this, especially now, I think, with being in this COVID era, let's say you're in New York, for instance, and your equipment supplier is out in Southern California. So in real time, when you're trying to fix or diagnose an issue, you can have a session with someone remotely and begin some remote diagnostics of the system to help repair, to give insights, and also whatever you decide to do for as troubleshooting, you have your digital twin that can validate your hypotheses.
Okay, very good. In terms, so that's also something else that an engineer is going to have to get used to, is like viewing things through AR headsets and things. Are there any? Oh, there we go. Man, look at that. Are there any other ways that in general the advent of digital twins are going to change the practice of engineering? I mean, not just like in the skill sets needed for specifically for digital twins, but I mean, is it going to change the way that we think about products? That they're not just physical objects that are produced and sent out to customers, but that they also have, since you're getting data back all the time, and it sort of increases the whole idea of a product as a service rather than as a physical object. Does that even make any sense?
Yes, go ahead, bro. I'll let you take this.
No, I was just going to say that the change that will come about, right, is when you're offering your product or your equipment as a service. It's no longer a case where you make your product and then you sell it to your customer and then you forget about it. Now that you're running it as a service, you have to continuously be monitoring what's going on and how it's getting used. You have the opportunity to better understand how your product is performing. So from an engineering perspective, you are now required to be on a constant on mode, where you're recognizing how your machine or your equipment or your product is getting used, and being able to make appropriate changes as necessary. Not always necessary, but as necessary, right? On a real-time basis, number one. And number two, then obviously in the next generation, right? So the engineer now is no longer someone who's going to sit back and design a product and let the sales team and the service team address the needs or the issues in the future. The engineer will need to become very closely connected to the product usage as well, and really understand how the product behavior is how the product is behaving in real time, and then make any necessary changes.
And I would like to add, just listening to what Ro just said, it really made me think of kind of the Tesla model with the vehicle. It's continually improving. So I see similar products using digital twins. You'll be able to do that, let's say, with a hot water heater that's connected to the internet and has software to be able to, over time, improve itself just by sending an over-the-air update. If that makes sense.
No, that makes a lot of sense. So I mean, it'll be the products will be continually connected to the manufacturer. They'll be improved upon over time.
Yep.
But also, I mean, I guess in a sense that you lose as a customer, you lose a little bit of control over it too, because I mean, there's always the idea of like the corporation coming in and bricking your thing if you don't pay the service fee or whatever. But I mean, there's a good side and bad side of that. But I mean, also from the point of view of the customer, in addition to, like, especially a heavy equipment customer who's dealing with sales reps and stuff, other than dealing with the engineer more closely, because they're getting this more granular information, are there other things that customers are going to see from their products, if they're being mirrored in digital twin form? I mean, we've already mentioned, better maintenance because of predictive maintenance and all around better product design. Is there anything else that customers should be looking forward to in the future because their products are existing as digital twins?
Yeah, I mean,
go ahead.
sorry, go ahead. Go ahead. Go ahead. Go ahead.
One point I would just make, I think healthcare is going to see a lot of digital twins in the form of, let's say if you had a heart issue, for instance. I've been doing a lot of reading. I think there's things you can digest that can send like electrical signals back to a different device, and they can model and then run scenarios that way before surgeries and things. So I think the healthcare industry is prone to see the most disruption after manufacturing.
I mean, so they'll maybe make a full body scan of me, and then I'll exist as a digital twin.
Someday.
Yeah, I already have one twin, but maybe I'll get a digital twin. Mr. Garg, you wanted to jump in on that?
Yeah. I was just going to add, right, that as the adoption of the digital twin increases, we are already seeing some of that today in our consumer life, right? We have phones that are getting updated on a regular basis. So that to the concern you were raising, right, is that going to be intrusive in some shape or fashion? And I think we have recognized that there is a lot more value than the intrusion that may possibly come about as consumers, right? So that same behavior is going to start coming into our commercial and into our business lives, as well as is at least how I see it, because the value will start coming in, right? And customers will see the need to do that. And there are a lot of great things that can be done, right? If you want to make changes on the product, you don't have to wait for a service engineer technician to come out and you're waiting for a day, 2 days, 3 days. You get a flash and you get it updated. The Tesla example that Travis just mentioned, and it's there in every case, right? Right from your water heater to any other equipment that you may be using. So I think all those values will come in. You could be making parts in a digital manner, right? The whole additive manufacturing. So if you are somewhere in a far off location, especially in our business and heavy equipment, we have got construction backhoes and whatnot, and sitting typically in areas where people have not gone as yet, and something goes down, you need a part right away. You send a digital image of that part, and that part gets printed right on spot, and you get going right on. Right? So it adds a whole new dimension to how things could be done.
That's interesting. So I mean, the digital twin is not. It actually goes both ways. It can be, you think about the digital twin as something that's mirroring a physical asset, but the example you brought up was, the physical asset being made and to the specification of the digital twin. I mean, the digital twin existed first. That's very interesting.
Yeah.
I mean, in terms of additive manufacturing, it also seems like that would be something where digital twins would be almost a no-brainer, because I mean, those parts begin almost specified to the molecule as digital files.
Exactly.
So it would just be a matter of making sure that you get sensors embedded in, or find some way to get the information back from the additively manufactured part. Is that correct?
Exactly right. Right. So you not only get real-time feed as to how it's working, and then you can make any necessary changes, right? So that's where the value comes in. And it's going to be even more critical, right? Because people do not know, as you said, to the exact molecule, right? So we still do not know what are the material behaviors of many parts and how they will behave. So a digital twin can help you tremendously, right? To understand, hey, how is this behaving? Should I continue down this path? I've made a part that is 3 inches long. What happens if I make it 6 inches long? And I'll be able to get real-time feed of how things are working in that regard.
And I would just like to add one other piece. I think field service possibly could be transformed, because if you have, let's say, a windmill that's out in a remote location, you're paying someone a lot of money to go out and inspect that asset. Whereas if you have that whole wind farm that's digitized, you then can do remote diagnostics and do things remotely that enable, field technicians to service things. And ultimately that'll help the consumers, because you're going to get more reliability.
Okay. Well, this all sounds incredible. But I think we're going to have to leave it there today. Again, I'd like to thank our sponsors. Please make sure you check out the resource section on the console to get more information about them. Good folks, and without them, this wouldn't be possible. For more in-depth conversations on digital engineering, the other episodes of this series are available on demand through the, go to the page where you signed up for this episode, and you can see the other three. They're also quite good. Thank you all for tuning in. Rahul Garg, thank you. Travis Harris, thank you. And that's it for today. This is Jeffrey Winters, Editor-in-Chief of Mechanical Engineering Magazine, wishing you a great rest of your day. Thanks.